Good evening, students. We'll start with the class. In the previous class, we were solving problems based on projectile motion. So, what we had seen under projectile motion is any point you start or you throw a ball or anything, it will cover up some distance, then it will fall. So, you always start with your initial velocity u. So, every velocity vector will always have some components. If you're starting like this, it will always have a horizontal component, that is your ux, and this will always have a vertical component, that is your uy. And this is your theta. If you are throwing it at angle theta, this will always be your u cos theta. This will always be u sin theta. Right this side, this is u. Now at randomly, initial velocity is called u. After that, any other velocity is always represented in terms of v. So if you are looking over here, suppose this is your v. This will be your vx. This will be your vy. Vy will be different, but your vx will always be same as your ux. Your horizontal component always remains same. Then over here, maximum point weight in Vy is 0, but your Ux, Vx will always be same as your Ux. This will never change. Then over here, again, Ux, Vx will never change. It will be same as your this only, which is equals to u cos theta, which is equals to u cos theta. Same thing. Whatever is here will remain throughout it. Only your Vy will become ulta, minus. So whatever if it has started with a positive one, here it will be minus on the other side. We had seen time taken, total time, that will be time taken to reach up will be same as time taken to reach down. Then this was called as a range. This was a maximum height. Okay, and then we had derived some formulae. And then acceleration. So we had seen x component and always the y component. So this is for initial velocity, initial one. This is ux, and this was uy. So which is ux cos theta, u cos theta. This was u sin theta. Same way we had final velocity. So this would be Vx, this would be Vy, which is same as your u cos theta. This will be different. This we don't know. This we have to calculate. This is same as your ux. Then acceleration we had seen always along your x direction, acceleration is 0 because gravity is always in the y direction. Acceleration in the y direction was minus. Around horizontal, there is no gravity. So that's why along x direction, this will always be 0. So we have derived time, we have derived maximum height and horizontal range. And one problem we had solved based on that. One more problem. Question is, a ball is thrown with 50 meters per second at an angle of projection 37 degrees. Find first one, velocity and speed of particle of the ball after 2 seconds of projection. Second is angle it makes after 2 seconds of projection. Third is displacement after 2 seconds of projection. So this is a question. Now first we'll draw a rough diagram, same like a normal one which you draw. So this is 50 degree, sorry 37 degree, and this is 50, U is 50. Main one is 50. The U which is been starting, that is at 50. Now, this will always have a horizontal as well as vertical component. This will be your UX, this will be your UY. Now after something velocity and this after 2 seconds has been asked. So after 2 seconds, consider it had reached here after 2 seconds. We don't know. Maybe time was 2 seconds. After 2 seconds, it reached here maybe. So we'll consider any random point. Okay, we can put here. We don't know exactly where it is, but just for your diagram point of view, maybe it had reached here after 2 seconds. So this will be a velocity at after 2 seconds. So that also will have component. So this will be Vy, it will be a Vx. We will consider at t equals to 2. This must be your V. So we'll write all the data first, x-axis and the y-axis. We take acceleration due to gravity as 10 meters per second square. Now, what all data we'll write? This is x, and this is for y. The initial velocity we will write. U is 50. What is the x direction? Ux. So which is the ux or u cost it to calculate. So this will be 50. Theta is how much? Cos 37. And in the previous class only I taught you if the angle is 37, then what should be your triangle? This is 3, this is 4, this is 5. So cos theta is how much? Always adjacent upon hypotenuse. That will be 4 upon 5. Looking at the diagram. This is a fixed triangle. This will be 50 into 4 upon 5. So Ux is 40 meters per second. Same way calculate uy. This for y. So this formula is use sin theta. So 50 is remaining same. Sin theta will be, check in the diagram, this is sin 37. So this is opposite upon hypotenuse. So sin 37 value is 3 by 5. So this is 30 meters per second. So vertical component is 30 meters per second. So we are done with u. Now we'll see what is the final velocity. Final velocity means at t equals to 2 seconds at this point. Can anyone tell me what is Vy or Vx, sorry? What is your horizontal component value? What is the value of this? Horizontal component, I told you, will always remain the same, no matter where you are checking. So what it will be? Vx? 40 meters per second. Yes. So Vx will be same as your Ux. So this here, which we have already calculated, 40 meters per second. Vy we don't know. We have to calculate. Then acceleration, Ax is 0 always, and Ay is minus c, because it is in the negative direction, always gravity. So that will be minus 10 v. Now we have to calculate the velocity, that is Vy. So in order to calculate the velocity, we have to use the kinematic equation. So we know what is this? V is equal to u plus Et. We know this. Now obviously everything is in terms of components. So we have to use the components. So Vy we have to find out. So obviously it use Vy here. So if this we are using y, everything will be in terms of y. Not time, sorry. This. And now substitute your values. So this is obviously y component. What is uy? 30. A is minus 10. Time is 2 seconds. Given to you. Now calculate, and that will give you a Vy. So that will be 30 minus 20. That is 10 meters per second is your Vy component. Now velocity we have to always write in terms of vector. So we have your Vx component, we have Vy. So Vy we got as 10. So all our table is complete. So velocity is been asked as per the first question. So velocity after 2 seconds we have calculated. So we know that velocity is nothing but Vx plus Vy. So Vx how much we had got? 40. So definitely x direction means always you have to put I cap. And here we got as 10. 10 j. So that's the velocity. So this is how we have to calculate your velocity. Now, first part only velocity and speed has been asked. Velocity means vector. speed means value. How to find value of this? Anybody remembers? Vector I want to convert into magnitude of value. So what is to be done? Speed means always the magnitude part.
X square and Y square.
Yes. So we have to find magnitude of v. Speed is always pure value. That is nothing but magnitude of this. So 40 square plus 10. Okay. So that 40 square will give you 1600 and 10. So then root of that around 41.23 meters per second. The first part is done. Now we have to find what is the angle. Consider we have where we were checking. After 2 seconds we were here. So we have to check this angle now. Theta is how much? So here what we had V, we had Vx, this was Vy. So we want to find theta, no? It's nothing but you can use directly. Now you can remember. You can use tan theta formula. Tan theta will always be what? Opposite upon adjacent. It's like this. If you have Vx and you have Vy, and I want to calculate suppose this angle. So basically I want to calculate the angle between this Vx and Vy. So if I use the same vector here, this will also be Vy. Same vector, this same it will. So this is adjacent side, this is opposite side. So if I want to relate them, I can use what? Tan theta form. Tan theta is nothing but opposite upon adjacent. And then I can find theta is tan inverse of this side. So whenever you know any two components and you want to find angle between them, you can use tan theta formula. So tan theta is nothing but Vy upon Vx. So you know what is your Vy value and you know what is your Vx value. So just substitute them. So Vy value we had got as 4, sorry 10, and this Vx was 40. So 10 theta is nothing but 1 by 4, 0.25. And now theta will be tan inverse of, just go in your normal Google, okay, type like this, arc tan of 0.25. You'll get a calculator, scientific calculator. Just type in the Google arc tan of, tan inverse is also called as arc tan of this.
Miss, how we are getting at 41.23?
Root of 1700, not getting. Square root of this 1600 plus 100, no? Square root of 1700. Understood?
Yes, Miss.
Arc tan of 0.25. Just type and see how much angle you are getting. How much?
0.244.
0 point you are getting. Angle. Let us just check. I'll go type and see. Okay, angle in degrees you have to tell. Huh? That angle which you are telling me, no, that is in terms of radians. We'll have two options there. See, whenever you type in the calculator, no, one will be in terms of degrees, one will be in terms of radians. So tell the degree one. So it is something 14 point something is there. So it's 14 degree. Okay, 0.0 something will always be in terms of radians. And write in terms of degrees. Both the options will get. So the second part is done. Then the third part. Calculate the displacement. So displacement formula and use. Displacement is also a vector. So we'll again have x component as well as y component. If simple distance was asked, it would be different. Now displacement is both x and y. So we have this data. U was how much? Ux was 40, uy was 30, vx we got as 40, vy we got as 10, ax was 0, ay is minus 10, then time is 2. So this all data we have. So now we'll use the displacement formula. So S is what? Ut plus half AT square. So this also part will have two things, Sx. So Ux everywhere you'll have to put x. Same way, Sy will be what? Uy plus, so wherever there is this, you just have to put y. So this will also have two components. Now accordingly substitute the values, you know all the values. So the distance, x will be, this will be 40. This is 2, half, this is 0, 80, this will be completely 0. X equal to 80 meter. Same way, put all the y values, you know. So this will be 30, ay is minus 10, this is 60, this will give you 5. So 2 square is 4, 4 5 are 20. This is giving you 40. So you got your sy component. Now just add. Same like how we were writing v. So s vector will be Sx plus S1. This will be 80, this will be 40. I cap and J. Now, suppose we want to know in terms of proper value, magnitude. Proper distance form will be 80 square plus 40. 8 square is 64, and this is square, so double the 0. Same way, 4 square is 16, and 0, whenever is square, the zeros also will double. So 6400 you have to add to 1600. That will give you 8000. Square root of 8000 will be around 89.44. So all the paths are done. So this is how we have to calculate velocity. If asked angle also and asked displacement. The only thing you have to know how to write your component. The trick is that this horizontal component will always remain same throughout the projectile motion. The ux will always be equal to vx. Next question. For a projectile motion, from ground to ground, the height is equal to the range. Find the angle of projection. Over here, the data given is h is equals to r. So you should know what is the formula for height and the range. Last time we have already done. H was we had derived, and range we had derived as to u sin theta cos theta upon g. Now whatever is getting cancelled, you can cancel on both the sides. G and g will cancel, one u will cancel, and one sin theta will cancel. Because sin square theta can be written as sin theta into sin theta. So what will happen? One this time will go with the square. One, this two and this two you cannot cancel. Only if the two was on top you could cancel. So what remains is after cancelling sin theta upon 2 is 2 cos theta upon g is gone. So angles you bring together. So this is multiplication. So this fellow will come down. 2 you can take up. Sin theta upon cos theta is tan theta. This is 4. So theta is tan inverse of 4. So just type arc tan of 4, and then in terms of degrees you will get, and one answer you will get in terms of what is that, this radian. So write a degree one. That will be your angle. Only angle was asked to be found. Next question. If maximum height is 30 root 3 and horizontal range is 120 meters, find initial velocity and angle of projection. So whatever data is there, you write first and then check what is asked. Maximum height h is given to me as 30 root 3. Range is given to me as 120. What is the h formula you write? So keep it as equation 1. Same way, what else we know? Range. Our formula we know as u square or 2u. U square, no? Sin theta cos theta. This will be, how much has been given? 120 has been given. No. Theta also I don't know, u also I don't know. I cannot directly solve these equations when I don't know two of the things. I put it as equation 2. But if you notice, these are having similar things. U sin theta, this also. So I try to get rid whatever is getting cancelled. So what I try to do is to get rid of this, I'll divide equation 1 by 2. Equation 1 divided by equation 2. Because directly I cannot put because I don't know theta also, I don't know u also. So it's like solving by elimination method. If there was plus sign, but whenever we have multiplication sign between two terms, you have to always divide. So divide equation 1 by 2. So left hand side will get divided by left hand side, right hand side will get divided by right hand side. So after dividing, it will look like this. This will get reversed. Sin square theta, one can write it as sin theta, or you can keep no issue. Keep like this only. This will reverse a upon b, c upon d. This one will always reverse. And now whatever is getting cancelled, it can one sign will go. G is there. So what remains is 4 cos theta. Again, what you do? 4 you take on the other side. So it will get multiplied. root 3 sin theta upon cos theta is tan theta. Tan inverse of root 3. These are standard angles. Normal trigonometric table will always have root 3. So tan of 60 degree. We know that tan 60 is what? Root 3. So directly theta is 60 degree. Only if you don't have standard angles, then you have to find. But root 3, 1 by root 3 is a standard angle. Because tan 30 would have been 1 by root. Now we got the angle. Now we have to find the initial velocity. So take any of this. You can take either the height or the range formula and calculate. Put value of theta either in equation 1 or equation 2. So what was the equation 1? 30 root 3 was theta we got as 60 degree. Now there's a square term, so just be careful. G obviously you can take it as without nothing is given, then you take it as minus 9.8 or else you can take 10. Whichever your teacher is asking you to put now, you can use that. Now what is sine 60 degree? U square. Sine of 60 is root 3 by 2, but there's a square sign, so we have to square it. Sine 60 square it is. The value of sine 60 you have to find first and then square it. And then just for simplicity, otherwise we'll take it as 10 minus 10. So this will become minus 20. Here, once again, no, we'll not take it as minus. Why, because what will happen? Minus root we will not be able to find. This is square on the other side. So G you take directly as 10 only. Because already it's a derived formula, no? So directly you can take G. Because before deriving, already we had substituted G as minus. And then minus minus had got cancelled. That's why we got it as plus G. So you put a positive value only. Otherwise it will become a problem. You cannot find root of negative numbers. So you take it as plus G only. So for this H, R, okay, and time, wherever there is G, no, take it positive only. Only when we are calculating the normal like components and all, that time we'll take it as minus. Because already while taking the derivation part, we took it as minus, and after that, finally we got it as G. So plain G only we'll have to take. Otherwise, you'll go back and check in the derivations of this formula. We had already taken minus G while calculating, and then at the end, after minusing, we ended up with plus G. So while substituting, you can take it as plus 1. Now this will be U square. Root 3 square will give you 3. It's like root 3 into root 3 will give you 3. This will give you 4. and then this will go up, this will come down, this, this will be 9. I can cancel 8, 800 into root 3. Into root 3 value 1.73. These no you normally by heart and keep on root 2 values, root 3, because they are commonly asked and you should not waste time in calculating this. Root 2 is 1.41. Root 3 is 1.73. Root 4 is anyways 2. At least these basic two roots you should always know. 800 into 1.7. 1384. Around 37.20 meter per second. So this is the initial velocity.
Teacher, why you took the value of g as positive?
Positive because see, if you take negative, you know, what will happen? U square root of negative answer will come. You can never find root of negative numbers.
Okay, teacher. Yeah.
And all the problems. Anyways, even for h, whether you're calculating range or whether you're calculating time, no, all these formulas, whichever are there, whichever is having g, take it as positive only. Because already while deriving, we already took negative. And both sides something was there and it had got cancelled in the derivation. You can go back and check for the derivation of height, range and time. We had already taken it as minus the component. And then it got cancelled with another one and became plus. Or if we must have taken it on the left hand side of the equation, then it became plus. But while deriving, we already took as minus. So no need to again put minus at it. It will become minus into minus plus. Next one, for a projectile motion from ground to ground, horizontal and vertical components of initial velocity are 6 meters per second and 8 meters per second. Find time, height, range and angle. Let's like this is your theta, this is your ux, this is your uy, this is u cos theta, this is u sin theta, this is your main. Now this time ux and uy is given. Main u is not given because the horizontal and vertical components are given. So ux is given to me as 6 meters per second. Uy is given as 8 meters per second. Nothing else has been given. So our aim is obviously find angle. Otherwise, if for time also, anywhere you see, you will need angle to calculate. So otherwise, what you can do, the formula is, this is what u cos theta. See, directly you can use this value also. What is ux? Ux is nothing but u cos. Same way, u sin theta is a. This is the equation 1 you can keep, and this is the equation 2 you can keep. Now what all we have to find? Time. Time formula is what? 2 u sin theta upon g. Now one simple thing here is 2 u sin theta. I'm just using it as a bracket so that you know where how the value came. This value u sin theta, from directly the value is 8. So directly we can substitute. Suppose we are using pen, then calculate. So that will be 8 by 5. By 1.66. So if you want, write and keep. From where I got this value? From equation 2. Look out for the value of u sin theta, which is already given to me as 8. Next, we have to calculate the height. Now there is a square term. What value we know is u sin theta. So what I'll do, this square is common in both. So square I'll remove out common. So this can be written as what? U sin theta the whole square. Because if you square, this square will belong to u also, this belongs to square sine also. So it's like taking square out common. And definitely you know what is the value of u sin theta now? 8. It will become 8 square upon 2 times your 10. Everywhere I told you, take positive only for this type formula. So 64 upon 20. Meters. Height means it will be always in meters. Third one, your range. To u square sin theta cos theta upon g. So we'll have to just arrange this first. Now sin theta is also there, cos theta is also there. In equation 1, who is there at the side of cos theta? U is there at the side of cos theta. And here double is there. So what I'll do, out of this u square, I can split u square as u into u. So one u I'll give it to this fellow. So I'm just splitting this u square as u into u. So one I'm giving here. And this value you know now. And this value also you know. This is 2 u sin theta will be 8. And this is 6. This will be 10. then calculate. So this will be 68, okay, 48 into 2, and then divide by 10. That will be 9.6 meters. Range is also in terms of meters. And last one is the angle. So I told you, whenever you have the two components and you want to find angle between them. So this is 8. Uy is given to me as 6. Ulta. 8 and this is 6. Then you have to always find what is tan theta. Is always uy upon uy. If you know the components and you want to find the angle between them, it's always the vertical component upon a horizontal component. So theta, tan theta will be 8 by 6. So theta will be, I think around 53 will get 53 degree. Okay, so this is how all the possible ways I have done. When angle is given, how to calculate, when initial velocity. When components are given, how to find it. All the three types I have done. Next is just a note, range for complementary angles. Complementary angles means always they are 90 degree different from each other. Means if theta is 30 and theta is 60, if you add both of them, it will give you 90 degree. Or other one is complementary angle. Will be 90 minus 30, which is 60. If I have theta is 60, then who is the complementary angle of 60? That would be 90 minus 60, that is 30. Same way, if I have theta as anything, you can take 50, then the complementary angle will be 90 minus 50, which is 40. So if we have like this complementary angles, so which are complementary angles? Theta and 90 minus. Initial velocity angle, then range is same. What it means is what? This, if I'm throwing at 30 degree, and if I'm throwing at 60 degree, the range covered remains the same, provided I'm throwing it with the same speed. And the two angles should be complementary to each other. If simply one I'm throwing at 10 and other one I'm throwing at 20 or 30, no, different range. But only if they are complementary angles, if you add both of them, they should be 90 degrees. Then in that case, the range covered is always same. So if you are throwing any ball at, suppose 5 meters per second, 5 meters per second, and the first one you are throwing at, suppose 50 degrees or 40 degrees, and the other one I'm throwing at 50 degrees. If the first fellow having range as 10 meters covering, then definitely how much is this is been asked. Suppose, okay, a ball thrown at 50 meters per second at 40 degrees is covering 10 meters. So how much range will the ball cover if thrown at the same speed but with 50 degrees? So in this case, you know that the angles are complementary to each other. So in this case also it will be 10 meters. You have to add distance here. 90, then no need to. If this is 45, this should also be 45. Next is formula for maximum range. Whenever you ask to calculate maximum range, till now what we were calculating was simple horizontal range. How much maximum the ball can cover. Suppose if it is asked, then the formula is only, usually it is what, u square sine theta upon g. Okay, u square sine 2 theta upon g. Now when we have to consider only u square upon g. Now what range formula is what? Or this is the formula. Usually I told you while solving the problems we use this. But in terms of theory, like if you have to derive, then it is this, because 2 sine theta cos theta is equals to sine 2 theta. So what is going to happen if you notice sine 2 theta is gone for maximum range. So that's like for the maximum angle it can cover, maximum range. So what is like the value of sine theta here? So we'll check angle for maximum range. How much will be the angle if you want to get maximum range? Like for javelin throw and all, like if you want to throw and you want javelin fall at the maximum range, cover maximum distance, then what angle I should throw at? We will calculate. So for that, this value should be equals to 1, because this should go. Only when this is 1, I'll get u square upon g. So for maximum range, the condition is sine 2 theta should be equals to 1. So 2 theta will be equals to sine inverse of 1. Sine of which angle will give me 1? 90 degrees. Theta will be, so sine 90 is 1 upon 2. So theta will be 45 degrees. So if you throw at 45 degree, then you will get maximum range. 45 it is. Now we'll see what is the equation for any trajectory path. If I'm throwing a ball, sometimes it can fall like this. Okay, so sometimes it can fall like this. It can fall proper in a circle, form half a circle. Sometimes it can go straight also. Depends on how I'm throwing. Okay, if I'm throwing it at an angle, it may go like this. But if I'm throwing at zero angle, it may go straight. Sometimes it can go straight. Sometimes it can go in a circle form, half circle. Sometimes it can go slightly like this. So this is called parabola. Okay, slightly not exactly pure circle. Other than that, if you're following, then that is called as a parabol or parabolic path. So in general, what will be the equation for any path whenever you throw something? So this trajectory path, whatever we are this trajectory is nothing but the path followed by the object wherever it is going. So whatever you have to derive has to have no time term. The answer should not have any t left in it. So this trajectory part will always tell you the relation between this help to relate x and y. It means what? Suppose if I have like this. These are like dotted, okay? This is the path. I just want to see what is the relation between x and y. Can anyone tell me what is the relation between the x coordinate and the y coordinate? Looking at the path. Whatever is the value of x is same as y. So the relation between x and y over here is x is equals to y. X coordinate is equals to y coordinate. Now suppose if I have like this. Now this is your x and this is your y. Now can anyone tell me what is the relation between x and y? X is half of y, x is double of y, what? Or x equals to y. What is the relation between x and y?
X is
X is 2 times your y. So any path will always help you. This is your path, suppose, will always help you to relate the relation between x and y. This is only for understanding, not to copy. Now we'll try to derive the equation for a normal path. Any path will consider now like this. This is your theta. So we'll consider up till here maybe. We'll take this distance as x and this part is y. This is u. This will always be a uy. This would be a uy. Suppose this is my u, the bigger one. This is my uy, this is my ux. So let me calculate the equation. Now first we'll write a component, x component and the y component. We'll write only in terms of u, acceleration and this. X and y. First we'll write what is my initial velocity. It will always have ux and uy. So this is u cos theta. This is your u sin theta. Next one, acceleration. Ux is ax is always equals to 0. Ay is minus. Here v we are not involving. V is not there. We are writing everything in terms of u. So u and acceleration. Same way, time if you want to write in x, this also will be, it will be time. Time doesn't have any component. Y also will have time. Now if you want to write distance for x and y. Continue after this now. The fourth point, want to do or the displacement you can. So this will have a x component, this will have y component also. X will come under here, y component will come under that. Looking at the diagram, can anyone tell me how much I have taken x this as displacement? What is the y this along the y axis? I have taken it as y. So directly you can put this is x, this is y. Value of x displacement along the x direction, I have taken it as x, and along the y direction, I have taken it as y. So whatever we are deriving is for the path. Okay, path means obviously the distance covered. So we'll use the distance formula for kinematic equation. So this is what we know. So obviously, I told you it will always have two components. So if we are using x component, everywhere x will come. If we are using y component, everywhere y will come. Now we'll just substitute the values here from the table. So this is the table. Both the sides will substitute the value. Ux is nothing but u cos theta. Time is there. This will be 0. Ax is 0. This will be t. And what is x, s of x? X. This is what it will be. And this will become 0. So this part is gone. Now y, this is value is y. Uy will be u sin theta into t plus half. This is minus g into t. So y is equals to u sin theta into t minus half dt square. I just substituted the values from the table. That's it. Now if you see, both the equations are having in terms of time. And I told you in the starting only, we have to eliminate that t. I don't want t in the final answer. So what I'll do is, I'll try to take the value of t from here and substitute this over here. So that t is gone. So what I'll do, what is t? As for this, x upon u cos t you keep there only. This one you take there. So value of t is what? X cos. This you mark as equation 2. Now what I'll do, I don't want this t over here. So put the value of t from equation 1 in equation 2. So what I'll get, y is equal to, this is the equation given to me, half gt. So wherever there is t, I'll put this. There's a square term, so it will get squared. So if you notice, now the entire equation has no t term left in it. Now whatever is getting cancelled, you can. So this will give you x sin theta upon cos theta. Or square all the terms. So you notice sin theta upon cos theta is 10. And it says gx square upon 2 u square cos square. So this is the answer. Now this will give you relation between x and y. So based on that, you can always tell what kind of path it is. Suppose if you have y, single y and single x, no, it will always be a straight line. This part if you have simple x and this part if you have simple y. In the equation, there is no power, then it is always a straight line. If you have both squares, no, then it is always a circle. If you have single y but x square, then it is always a parabola. So if you have any equation in terms of single x and single y, then it's a equation of a straight line path. If you have both squares, then it is an equation of a circle. Hence the going in circle form. If it's going like this, it's single y x square means it is following a parabolic path, slightly more like more flatter than a circle is always a parabola. Or even this is not exactly a circle, will always be a parabola. solve one problem. A ball is thrown from a tower of height 20 meters at a speed of 5 meters per second. Calculate time taken to reach the ground. Second, velocity vector or velocity just before hitting the ground. Just before hitting or when it hits the ground, it will be same. Huh? It's like just after hitting the ground. Anyways, at this point it is 0, so there is no point calculating. So whenever it is reaching the ground means just like before coming to rest, whatever is its velocity that we have to calculate. So don't write anytime 0 and keep because it reached the ground. This is not after reaching the ground. It's like when it is hitting the ground or just hitting the ground. Find angle. Okay. So now this is now from a tower. Just like we have a tower here. Now what is the difference between earlier also we have done tower problems, but there the ball was dropped. So initial velocity was 0 and then it was yet is thrown. So you're already giving it some speed, so it will not come like this straight. So it's like you're first throwing it. Okay. So dropping means it's like assumed like this, and throwing means it always follows some path. So if we are standing here and then throwing, so definitely it will go and then fall at some point. So this is 20 meters. U is 5 meters per second. So definitely it has a horizontal component and vertical component. This will be Ux, this will be Uy. Now it's not going up, it's to be considered like this. Definitely there's gravity. Now let us start writing the components. X component, Y component. So for initial velocity, U is given to me as 5 meters per. Now U is same as Ux now because it's going in the horizontal direction. So this is Ux also will be 5 meters per. Can anyone tell me what is the value of Uy? Is the ball going upwards? What will be the value of Uy at initial point? So when you're throwing, like throwing it in the horizontal direction. So the ball is traveling horizontal. So what will happen to the vertical component? What is its value? Just when you start, when you're throwing the ball, what is the value of uy? Is the ball going upwards? Suppose there's a car. The car is moving this side. What is its vertical component? Is it going flying in the air? What I'm trying to no. So what I'm trying to ask, is there any velocity of the ball in the y direction? No, definitely it's not. If there was velocity in y direction, it would have been going slanting upward. So whenever you are going straight on the road, your always vertical component is 0. So if it was like this, then it's like slanting. You're going in x as well as y. But if you're going straight like this, obviously this part is 0. So your uy will always be 0. Because it doesn't have a vertical, the ball is not going up. So same way, acceleration, ax is 0, ay is minus 3. Now, displacement, x distance. So I don't know how much it has been covering. This will be your x. So someone tell me what is the s of x and what is s of y. Look at the x distance. This of y I can tell. This is, I'm assuming to x in the horizontal direction. What is the displacement in the vertical direction? From how much height it is falling? What will be your s of y in the vertical direction? What is the height of the tower?
20.
Yes. But now the ball is coming downwards. So remember the rule, whenever it is going up, the displacement has to be taken positive. So whenever it is coming down, you have to take displacement always negative. That's why you have to take as minus 20. Why? Because downward direction. So that's why you have to take negative. And time has been asked to calculate. You have this formula, ut plus half at square. Now which part is easier to calculate is, we don't have any v we don't know. X component, if you take, you don't know x. There are two components, is x uxt plus half at square. Then you have y component, uy t plus half. Either of them you can use, but you have to see which one to use. In this case, we don't know what is s of x. This distance we don't know. So this will become unknown. T also we don't know. There will be two unknowns. We can't solve this one. Here what is happening? I know the value of s of y, that is minus 20. I know u also, that is 0. And I know ay also, that is minus 3. So only what is left is to find t. So I'll have to use this equation. Here what is happening? This is also unknown and this is also unknown. Two unknowns. So I will not use it. I will use this equation to find the time. Other ones I cannot use. The kinematic equation, u, this v is equal to u plus at also I cannot use. Why? Because I don't know what is v. I only know initial velocity. This one also I cannot use. V square is equal to u square plus 2a. So these two equations are having v in it and I don't know the v. So the only option I have is to use this equation. So substitute the values. This is minus 20. This I cannot use because 2 1. Uy is 0. A we can take is minus 10. that is minus g, you can put first. T square we have to calculate. This part will be 0 minus half gt. Now already we took as minus g, okay, which is the same as minus 10. So we have to take positive. Or directly we have to take ay as minus 10, however you want. Okay, and then calculate. Minus minus will anyways cancel. So that will give you 40 upon this. That will give you t square root of 4. The time will be 2 seconds. 40 upon 4 will give me 4, and then t square. The root of 4 will give me 2 seconds. So time is 2 seconds. First part is done. One more you add there in the question. Calculate the horizontal range. This you can use as to calculate horizontal range. Horizontal range means we have to calculate x. So we have taken it to be x, no? So that formula you use. Now this part was x. Now time you know. So you can always put your time and calculate. Ux was how much? 5. Time is 2. Acceleration is minus 6. X component, no? So this will be definitely 0. And this will be 2. X is 0. So answer will be 5 to the 10. And this is anyway 0. So that is 10 meters. Or even if it was asked horizontal range, no? So it means R. Nothing. This is the one, no? That's your X, which is same as your range. Then the third one, we have to find velocity. Now we have to calculate V. Third part is to calculate velocity. The ball is falling here. Your Vx, this is your Ux. Even after while hitting the ground, Vx will always be equals to Ux. So first part will calculate. I want to calculate what is my Vx and what is my Vy. I told you the horizontal Vx will always be same as Ux, which is already 5 meters per second. So one part is done. For velocity, we have to calculate both the components, x as well as y. So ux directly I got same as, because every way you calculate it always remains the same, the horizontal one. Now vy we have to calculate. So for that can use this formula. Now angle and all is not there, so you cannot calculate in terms of angle like v sin theta. And so this will be vy, because we are calculating vy, and use vy here, so all will become in terms of y. Uy is obviously 0, you can check in the table. Vy have to calculate, this is minus 3 into, that will be vy is given to as minus 10 into 2. It's falling down, no? So it will be this side of negative. This will be minus 20 meters per second. While coming downwards, the vectors will be like this, ulta, vx and vy. So that's why we'll get negative velocity, so just before hitting the ground. So v will be what? Vx plus u. This is pi cap, this is minus 20. Want to calculate the speed? Then take magnitude of root of 420. So that will be your speed. This is velocity. Speed was asked, huh? Then you have to do like in the last part, calculate your angle. I told you whenever you have to find the angle, always use this formula tan theta, when you know the component vy upon v. Your vertical component always upon your horizontal component. No need angle, no need to put minus and all, okay? Because negative angle you don't calculate. Normally you put a magnitudes only. So vy what we have got 20. Angle you put positive values. This only minus means only it is coming in the negative direction. And this was 5. Tan theta was 4. Answer is tan inverse of 4. And then calculate and write on in terms of degrees. So whenever a ball is thrown from the this height, and this is how you have to calculate. Only thing main for starting, you should write all your components. The table should be framed properly. Rest everything whatever is needed accordingly you have to use the equations and then calculate. So stop here.